All right, let's talk about one of the biggest moments in space exploration happening right now, Artemis 2. This is it. This is the mission that's finally, after more than 50 years, going to take humans back to the moon. Let's get into it. You know, it's almost impossible to overstate what happened back in 1969. The Apollo missions, they weren't just a technical achievement. They grabbed the entire world's imagination. It was one of those moments that showed us what we were really capable of, a true turning point. But here's the crazy part. For all the amazing things we've done since, rovers on Mars, telescopes that see to the edge of time, when it comes to sending actual people out there, we've been stuck. For 5 whole decades, we've gone any further. Well, that is all about to change. So why are we going back? What makes this so different from what we did in the 60s? Well, Artemis is definitely another giant leap. But this time, the whole point of the mission is different. It's really about laying the foundation for our future out in the solar system. And this is the key. We are not just repeating Apollo. The Artemis program is all about building a permanent human presence in deep space. We're using the moon as a testbed, a place to figure out new technologies, and as a launch pad for the next big destination, Mars. We're not just going back, we're going back to stay. And Artemis 2 is that first huge step. You can think of it like the ultimate test drive. It's a 10-day mission, 4 astronauts on board, and its whole purpose is to make sure this brand new spacecraft and all its systems can handle the incredibly harsh environment of deep space. Of course, a mission like this is nothing without the people, brave enough to strap themselves to the top of a giant rocket. So let's meet the 4 pioneers who are gonna make this historic trip. Leading the charge is Commander Reed Wiseman, a seasoned U.S. Navy pilot. Flying the ship is pilot Victor Glover, who's already been to orbit on a SpaceX Dragon. We've got mission specialist Christina Cook, who holds the record for the longest single spaceflight by a woman. And representing Canada, there's mission specialist Jeremy Hansen, a fighter pilot making his very first trip to space. I mean, what a crew! And the tech they're using? It's come a long way. The crew named their Orion capsule Integrity, and compared to the old Apollo capsules, it's got 60% more room and fits 4 people instead of 3. But honestly, the real game changer? A private space toilet. No joke. Back in the Apollo days, it was basically a hose and some plastic bags, which you can imagine wasn't great. This is a serious quality of life upgrade. So you've got this amazing new capsule. How do you get it all the way to the moon? Well, you need a new kind of rocket. And this crew is going to be riding an absolute monster. The most powerful launch system ever built by humans. Just look at that number. That is the thrust from a single one of its 2 solid rocket boosters. To give you some perspective, that's more power than 2 SpaceX Falcon 9 rockets firing at the same time. The raw power is just hard to even wrap your head around. And the size of this thing is just as wild. Each of those side boosters, they're as tall as a 17-story building. This is truly a mega rocket, the most powerful booster ever designed to carry humans. And this wasn't just built by NASA alone. This was a massive nationwide effort. The Space Launch System rocket, the SLS, and the Orion capsule were built by over 3,200 different companies and suppliers from every single state in the US. The launch itself is going to be this incredible, fast-paced sequence of events. At T0, the 4 main engines light up. Just a few seconds later, those 2 massive solid boosters ignite, providing 75% of the total power and a sound that will shake the ground for miles. And things move fast. Just 2 minutes in, the boosters are gone. 8.5 minutes, the huge main stage is done. And by the 20-minute mark, the crew is flying free in Earth orbit. But just getting to orbit is only the first step. Before you commit to a 400,000-kilometer trip to the moon, you have got to be absolutely sure your brand new spaceship works perfectly. So how do you even do that, right? When you're thousands of kilometers from the nearest mechanic, how do you check that everything, especially the manual controls, works exactly like it's supposed to? Well, you do it with a simulated docking. It's actually really clever. First, the autopilot flips the Orion capsule completely around. Then pilot Victor Glover takes over the manual controls. He'll use the big, spent upper stage of the rocket, which is still floating nearby, as a practice target. He'll line up the capsule and fly towards it like he's about to dock. They won't actually touch, but this is a critical test of the controls they'll need for real dockings on future Artemis missions. Okay, all systems are go. It's time to light the candle. The crew will fire their main engine and start the long 4-day coast to the moon, traveling farther from Earth than any human being in history. And during that 4-day trip, the crew becomes a science experiment themselves. They'll have wearable sensors to track how deep space affects their bodies. They'll test out an emergency radiation shelter, and, of course, they will capture what are sure to be some absolutely historic new photos and videos of that iconic Earthrise. And here's something really cool that's different from Apollo. They're going to fly past the moon in this really wide arc, about 10,000 kilometers above the surface. That is much farther away than the Apollo missions got, which means this crew will see more of the lunar landscape in a single view than anyone has ever seen before. So after they loop around the moon, the crew starts their 4-day trip home. But the mission saves its most intense, most dangerous challenge for the very, very end: re-entry. Look, we have all seen astronauts come back from the International Space Station, but coming back from the moon? That's a whole different ballgame. As you can see here, they will be slamming into the atmosphere at over 40,000 kilometers per hour. That is so much faster than a return from low Earth orbit. And all that extra speed creates a massive amount of energy. And where does that energy go? It turns into heat. The heat shield on this Orion capsule has to survive temperatures over 2,700 degrees Celsius. That's about half the temperature of the sun's surface. This is the ultimate test, and there is absolutely zero room for error. But assuming everything goes right, the Integrity capsule will splash down safely in the Pacific Ocean, where a recovery team will be waiting. And with that successful splashdown, this historic test flight comes to an end, and a whole new era of human exploration truly begins. And really, that's the whole point. We've already walked on the moon. Artemis 2 isn't about repeating history. It's not some rush to just plant another flag. It's something much, much bigger. It is the beginning of humanity's next great chapter in space.